Okay, our goal on this problem is we are given a linear function, 7x plus 10. Our goal is to find k prime of x using the limit definition. Ours just happens to be k is the name of the function, so it'll be k prime that we're trying to find. So let's jump right in here. We want to find the limit as h approaches 0. And we're going to fill into that formula that's over on the right-hand side. So the first thing we want to do is replace we'll replace the x with x plus h. So this will give us 7 times x plus h plus 10. That kind of corresponds with what we have on the right-hand side, the f of x plus h part. From that, we're supposed to subtract the original function. So I'm going to replace where f of x is, really that's k of x, is 7x plus 10 gets filled in there. This is still all over h. Now we're not allowed to plug in 0 for our h because that would be dividing by 0 at this point. So let's work on doing a little bit of simplifying down. The simplifying down I'm going to suggest is let's bring along the limit as h approaches 0 until we're allowed to substitute in. We can go ahead and distribute the 7. So that'll leave us with 7x plus 7h. Bring along the plus 10. I'm also going to go ahead and distribute this negative. It needs to be applied to both of these terms inside the set of parentheses. So minus 7x minus 10 all over h. Okay. From here, we do have some like terms. If we think about simplifying down, combining like terms would be a great start here. We have 7x minus 7x. That makes 0 x's. And we have 10 minus 10. So those eliminate each other. So let's think about this. We have limit as h approaches 0. And what remains is simply 7h over h. Well, we can eliminate that common factor between numerator and denominator. We can say, well, h over h makes a 1, so those can go away, and we're really just looking at the limit as h approaches 0 of 7. Now, we don't have any h's remaining in our function, so what we can do is that's simply going to equal 7. Well, let's think about why that equals 7. Our original function was linear, meaning that if we were to graph that, the graph would be a line. All right, and it would be a line with a y-intercept of 10 and a slope of 7. So if we drew any tangent lines to this graph, they're all going to have the exact same slope as that original graph. So it kind of makes sense if we think about the derivative means the slope of tangent lines, why the derivative turned out simply being the exact same as the slope of our original line. All right, because it was a linear function. All right, hope this helps out as you're working with the limit definition of derivative and finding the derivative and the slopes of tangent lines. Good luck.